Hello everyone, my name is Emmanuel Courtoux from Université Paris-Saclay. I present the SurfAirs project I've worked on with Appert and Olivier Chapuis. In this project, we were interested in interacting with large vertical displays with tangible controllers. Interaction with large vertical displays can happen at different distances. On the one hand, users may want to interact directly on their surface, for precise manipulation and a better vision of details. On the other hand, they may also want to interact from a distance if they need a wide field of view or to make large-scale manipulations. Supporting both close and distant interaction is key to let users move in space and that way fully benefit from both the high resolution and the large size of the whole display. Projects enabling tangible interaction for large vertical displays often propose on-surface or distant interaction, but not both. In the SurfAirs project, we propose a single tangible controller enabling both surface interaction and distant interaction. As users of large vertical displays often switch between surface and distant interactions, we wanted to enable continuous transitions between these two interaction spaces so that users can combine precision and a large range of motion during a single interaction. We iteratively designed two prototypes. The challenge was not only to track the controller when on surface and in the air, but also to design a switch that enables users to either maintain control on when they leave the surface or to start controlling from a distance. The first prototype is what we call the torch prototype, as it is held like a torchlight. It is designed to be orientation independent and allow users to always activate the switch no matter the way they grab it. This switch is a gear linked to a spring that user can slightly press to activate. The second prototype, the handle, used the metaphor of a door handle. This type of SurfAirs is designed to support a specific hold. The switch is a push button that is located just under the user's thumb. For both types of SurfAirs, we relied on infrared markers and the motion capture that is available with our wall display. We use this system to track both the position and the state of the switch. As this video illustrates, our SurfAirs allow continuous interaction in between the display surface and away from it. We conducted two studies to evaluate our SurfAirs prototypes. The first one focuses on distant interaction and considers bare-hand gestures as a baseline. It is divided in two phases. The first phase is a simple point-and-click study where users are instructed to reach targets of different sizes and click inside. Here is a quick example of what the task looks like. To perform a click action, participants rely on the SurfAirs respective switches for the conditions where they are used as controllers. For the bare-hand condition, participants clicks by performing a side trigger gesture. For this distant pointing task, SurfAirs are faster, less prone to errors, and preferred by participants. For example, in this chart, you can see the completion time along the y-axis by input condition and target width. We can see that the light and dark blue bars that correspond to both SurfAirs are lower than the gray one that correspond to bare-hand input. We can also see that the handle prototype outperforms the torch prototype. In the second phase of the first study, users had to perform a docking task from a distance. It requires participants to move and rotate a square-shaped graphic object, here in blue, to match a placeholder position and orientation, here in yellow. Here is a quick example of this docking task. For this second docking phase, both SurfAirs prototypes are faster than bare-hand input and are overall preferred. For example, in this chart, you can see the completion time along the y-axis by input condition and target angle. As for pointing, the light and dark blue bars that correspond to both SurfAirs are lower than the grey one that corresponds to barhand input. For the second user study, we focused on the continuity in between surface and distant interaction. Given that the handheld prototype performed better in the first experiment, we decided to keep only that tangible controller for this second study. Here again, we assess SurfAirs performance using barhand input as a baseline. For the surface to midair task, participants start by matching scale and orientation of a placeholder before taking control of the virtual object over mid-air. They must then drop the object in a different placeholder positioned either left or right of the display. We evaluate two techniques for the transition from surface to mid-air. The grab requires, while being still in contact with the display surface, to press the switch with the handle or to perform a side trigger gesture with the barhand condition. The second technique, the flick, does not rely on the physical switch, leaving it available for other purposes if needed. To transition between the surface and the air, while maintaining control, participants perform a flick gesture either with their finger or with the SurfAirs before leaving the surface. For the second type of task, mid-air to surface, participants grab a virtual object from a distance before dropping it on the display surface on a specific placeholder. We then make the orientation and scale of the virtual object precisely match that of the placeholder. In this task, for transitioning from mid-air to surface, participants just come in contact with the wall. Here are the study main results. For example, in this chart, you can see the completion time along the y-axis by type of transition, air to surface or surface to air. For surface to air transition, we also see the two types of transition, flick and grab. Overall, handheld SurfAirs are significantly faster than barhand input in all tasks and conditions. In each bar, there is a vertical breakdown to show the different phases of the movement. In the air, on surface, and transition. We can see that there is a benefit in using SurfAirs for each of these phases. In the final questionnaire, participants also ranked SurfAirs as their preferred technique. To wrap up this presentation, I summarize our contributions with the SurfAirs project. We proposed tangible controllers that are adapted to the interaction space of large vertical displays. SurfAirs combine in a single tangible controller interactions directly on the surface and in the air, as well as continuous transitions between the two. We reported on two user studies where the SurfAirs controllers were faster than barhand input and were preferred by participants. If you want to learn more about this project, I invite you to read our article, to visit our website, or to contact us directly.